here we go. Let's talk about number 6. No one. Oh, Kyle put number 6 up. Okay, here we go. All right, so Kyle's to the left here. We need to solve for the question mark that is up here in the corner. Okay, so you just started going through and figuring out what your angles were, right? You did not know originally what this angle was, but you knew these two angles. So then you used that information to find your angle in the middle, right? So you did 180 minus 37 minus 22 gave you 121. And then what's that guy going to be?
They're vertical, so they're the same.
Very good. Vertical angles, so also 121. So then you subtracted from 180, 26 and 121 to end up with 33 degrees. So you got 33 degrees for that question mark. Very good. Okay, cool. Let's talk about 8. So 8 is here. We're going to look at it up on the screen up here. All right, I need to figure out what x is. Okay. Now, this is a bit tricky, right? Because like 7x plus 9, where is that angle supposed to be? It's supposed to be angle F. So 7x plus 9 is supposed to be this angle right here. And then angle E is down there, okay? So what you're supposed to do, and I know that picture is like really misleading, what you're supposed to do is add together 7x plus 9 plus 20, and then set it equal to my exterior angle, which is 5 plus 9x. That's how you're supposed to go about doing it, okay? All right, so then we're going to have 7x plus 29 equals 5 plus 9x after you combine like terms. Subtract 7x from both sides, subtract 5 from both sides. You get 24 equals 2x. So you should have had x equals 12. That's what you should do for that one, okay? All right. So there's through 8. And then let's just go through, and I honestly think we can do all of these. But I think we can do them pretty quick, okay? So for this first cluster of problems, let's look at 3 through 5 now. So the first cluster of problems, which angle should I find first? What do you think? There's a couple ways you can go about doing this. Which angle could we find first for this one? General reminder, make sure that you guys are, I mean, honestly, at this point, there's no reason why your iPad should be open, right? We're going over a worksheet that is pencil and paper. Shouldn't have our iPads open. We should be focusing on just this worksheet, okay? Angeline, where'd you start first?
I started by finding angle 2.
Okay. And really, you started by finding that angle and then thought about it like vertically, right?
Yeah.
So you did what? 58 plus 39, which gave you what? So 97.
Yeah, 97.
And then 180 minus 97, which gave you 83. Good. So then that was this guy right here, 83 degrees. So we know, because it's vertical, that angle 2 is also 83 degrees. Cool. And then you could pretty easily find what angle 1 was, right? Because it's supplementary. Which would be what? Measure of angle 1 is?
Oh, 97.
Good. Which comes, honestly, from here. Because you could think about these two angles being the remote interior angles to angle 1. So you could have done it that way as well, too. All right, we need to find 3. So, Angeline, I imagine you did 80. That's not an 8. 83 plus 35. Add those together to get 128. No, that'd be 118. My bad. And then you would subtract that from 180 to get that that's equal to 62. Is that what you got for angle 3? All right.
Yeah, I mean, I didn't do it.
Oh, okay. So 62 degrees. Okay, cool. Oh, yeah, because it was yeah, okay, cool. All right, and then if I forgot that I didn't have you guys do all of them. Okay, so then to the right, we've got a lot of different angles in there, okay? So if I were to have this picture, here's where I would start. I mean, there's a multitude of places that you could start, okay? I would probably start with, like I would say, okay, I could find this, I have to find angle 1. So I could add those together and that'll tell me what angle 1 is. So if I do add together 68 and 36, that would give me 104. So that would be measure of angle 1, is 104. And then I know that this is 36 because those are vertical to each other, okay? And then from there, I mean, you could do something like, you know, you could find the measure of angle 6. you'd have to add together these values right here. So 65, let's do it right in line. 65 plus 82, which is going to give me 147, I think, or 47 degrees. So that'd be the measure of angle 6 is 147. All right. Well, I could find the complement of that to figure out what this angle is. Or I guess I don't necessarily have to do that. But one thing I could do is I know this is 180 between 70, 65, and angle 4. So you could subtract from 180, 70 degrees to get 110. And then 110 minus 65, which is going to be 45 degrees. So then that would be measure of angle 4. Oops. All right, so this is 45. So now I know this angle. I can figure out this angle pretty easily, 62. And then I could easily find angle 5 after that, okay? And then once I know this is 45, I can subtract those from 180 to figure out what 3 is, and then I could use that to figure out angle 2, okay? So I'm not going to go through and figure out what all those are, but that's how I would go about doing any one of those problems, okay? All right, to find the measure of each angle if BAD and BDC are right angles. So those are listed in the picture. And ABC is going to be 84 degrees. So ABC, this whole big angle, would equal 84 degrees. So we'd have to keep that in mind. Okay, so we need to find angle 1 and angle 2. Well, I would start by finding angle 1. And then subtract. So I know that angle 1 has to be complementary to 64 degrees. So then if I do 90 minus 64, I get 26. So then angle 1 is 26 degrees. And the difference between 26 and 84 is going to give us, I don't know, 58. So 58 degrees would give me what that angle is. And then complementary to 58 would be what angle 2 would be, which would be 32. So angle 2 is 32, and then angle 1 is 26. Okay? All right. Any questions there? Okay. All right. Was this section better than last section? 4.2 better than 4.1? Hopefully. Okay. All right. Today we are going to do section 4.3. So if you haven't already pulled up your notes for 4.3 from Google Classroom, please do that. After we do 4.3, I'm going to give you guys a bit of a review tomorrow, and then Friday I plan on giving you guys a quiz on 4.1 to 4.3. I think that's what my game plan is. After I sit down and look at this again, though, I'll think about that. But I think as of right now, that's when we will take a quiz. It's Friday, 4.1, 4.3. Let me take attendance. Are we missing anyone? I see all your smiling faces. All right. We've talked about congruence a decent amount so far this year. But my friends, we are about to do a tremendous amount of congruence, particularly with triangles. Okay? So we're going to do a lot of stuff with congruence, talking particularly about triangles. And as I think I'm walking around, I don't know if anybody has what they're supposed to have up on the screen. Very few of us. Very few of us. So I'll put it this way. Going forward, if I see you on your iPad or catch you on your iPad, whether it's me like walking around and seeing it, or if I am monitoring it on my computer and I see that you have an app up that you shouldn't have open, or playing a game or whatever, that's a warning. So this is like your first official warning. If I see it again, I will give you guys a warning and email home. And then after that, then we might have to look at some detentions. Okay? So I need you guys, like if you're in here in class, we're working on stuff, especially if I'm lecturing, or even if I'm going over homework that you already completed, it is not time for us to be playing just any sort of game or doing something we're not supposed to be doing. Okay? And then I want to keep it math in this class. So if we're not working on like an English assignment or anything like that. Okay? But I think we've gotten to that point. I walk around and it's like very few of you are doing what you're supposed to be doing. So, all right. Today we are going to talk about, like I said, exploring congruent triangles. We know what congruence means. Congruence would be same size, same shape. The main thing we're going to focus on is corresponding parts of congruent triangles, okay? So in order for triangles to be congruent, that means, like if I'm talking about two separate triangles, that means all of the sides of one triangle have to be congruent to all the sides of the other triangle, and all the angles of my first triangle have to be congruent to all the angles of my second triangle, okay? So how many pieces is that? If it's all the sides and all the angles between the two triangles, how many pieces is that? 6. 3 sides, 3 angles. So you'd have 3 pairs of each. So then that would give you 6 pieces that we'd have to show are congruent. Okay. Things that are congruent of the exact same size and the exact same shape. The size is held together by the side lengths, and then the shape is held together by the angles. Okay. And when figures are congruent, their corresponding sides and their corresponding angles are congruent to each other. Okay. So for example, I have that these two triangles, ABC and RTS, are congruent to each other. Okay. So what I want to do is I want your help in writing what's called a congruent statement. Okay. I think I have that listed somewhere else in here. Yeah, congruent statement. But let's write a congruent statement for our picture here. Okay. Okay, so congruence statement. All right, so when we write a congruence, order matters. The order in which we list our letters is very important because it has to follow through the same order of both triangles, and all the corresponding pieces have to match up, okay? So someone give me an order for that triangle to the top there. So the A, the B, and the C. What order do you want to list those letters in? It can be any order. It doesn't matter. Okay, fine. ABC is the obvious choice, right? So triangle ABC is congruent to... When I list my second triangle, this is when order really matters. I want to list those letters such that they correspond with the letters that were given to me the first time, okay? So angle A is up here, right? How many arcs does angle A have associated with it? Okay, so I need to write the letter that has 3 arcs next to that angle, which would be what? Down below, R. So triangle R, let's do the same thing. So you guys picked B second. So actually we can do this in colors because we have the technology. All right, so then we did an R. So we're doing B next. So Dom, you're saying that B should go with S. Okay. So then I'm going to put S there, bless you. And then last but not least, C has 1 arc next to it, as does T. So then T would be my last letter. Okay. That's true. It does. The other thing that I wanted to point out, and that won't always be the case, but the other thing that I wanted to point out, I started by talking about like the angles match up with each other, but the sides should as well, okay? So if I listed my angles, I'm going to do that here, okay? We said that angle A is congruent to angle R, angle B is congruent to angle S, and then angle C is congruent to angle T. I want you guys to write this out because this is what you guys will be doing in your homework is a good amount of this, okay? Listing your congruent angles, and then let's list our congruent sides. Okay, so these would be the sides that correspond with each other. All right, so pick a side in the top triangle. Remember, when you list a side, you give me 2 letters. So just give me 2 letters from the top triangle. AB. So AB is going to be congruent to what corresponding side from my other triangle? So AB's got, you'll notice it has 2 tick marks on it, right? RS. Not RS. Oh, no, you're right. Sorry. I was looking at AC. You're right, Liam. AB has 3 tick marks on it. And RS, like Liam said, also has 3 tick marks on it. So we would say RS. All right, what's another pair of congruent segments? You said what, Ryan? BC would be congruent to what? ST, good. Now, I don't care about if you said BC is congruent to TS instead of ST. I don't really care about that, okay? As long as the letters are there, the appropriate letters, and that is what matters to me, okay? All right, what's my last pair of congruent sides? I did AB and I did BC, so my last side would be what? AC would be congruent to what? RT, good. Yeah, RT. All right, cool. You guys will be doing that a couple times for your homework tonight, is listing all of your corresponding sides and all of your congruent corresponding angles, okay? Now, the other thing I wanted to show you is if I write my congruent statement appropriately, I don't even need a picture, okay? If you look, we picked A and R to be the first letters, so those are going to go with each other. So B and S were the second letters. Angle B is congruent to angle S. And then C and T were the last letters, so angle C is congruent to angle T. So if I list my congruent statement appropriately, all those pieces should line up. Same things works with segments as well too. So like if I did segments, if I started with the first two letters AB, that should be congruent to RS. And we see that that's what's listed here. AB is congruent to RS. If I say BC, that is the last two letters. That should go with the last two letters of the other side, which would be ST. So BC is congruent to ST. And then first and last would be AC and RT. And those ones are the ones that are congruent to each other as well too. Okay, so order matters when we do our congruent statement. Okay. Liam already told us this, but for triangles to be congruent, that means that all 6 corresponding parts are congruent. So that is what's called our definition of congruent triangles. At the end of this section, we'll be doing a couple of proofs. So we'll be using that as our reason, as our final reason for our proof statement is definition of congruent triangles, okay? All right, let's do this again. Let's list all of our corresponding parts for our picture down below here, okay? So given ABC is congruent to TRQS, list all of your corresponding parts, okay? How many sides do I have? 4. So I have 4 sides, which means I should also have 4 angles. So how many pieces am I going to list here?
4.
More than that. 4 for each one, so 8 total, right? So 4 sides and 4 angles, okay? All right, what do you guys want to do first, sides or angles? I'm just going to go around the room and make sure you guys are with me. What do you guys want to do first, sides or angles? Doesn't matter. Okay, sides first. It's the harder one. All right, who can give me a pair of congruent sides in my picture? Now, I didn't mark anything in my picture, and sometimes that helps. Kyle, what do you got for me first?
AD and TS.
Okay, so AD, and you said what?
TS.
TS. Now, if you look, A and D are the first and last letter. T and S, also the first and last letter. So I'm going to put 1 tick mark on each one of those, okay? All right? And actually, let's make our life a little easier. Let's just put all the tick marks in my picture now. What other segments can I put tick marks on? Like, what should I put 2 tick marks on? If I use my congruent statement, A, B, and TR, right? So AB, we're going to put 2 tick marks there. TR, I'm also going to put 2 tick marks there as well, okay? And then if I did, the next 2 letters would be BC and RQ. So BC, 3 tick marks, RQ, 3 tick marks. And then last but not least would be CD and QS. So then CD, I'll put 4 tick marks. And then QS, 4 tick marks, okay? That should make it even easier to find my sides. So Kyle, you started by saying AD and TS, right? Okay, so AD is congruent to TS. All right, someone else. What's another pair of congruent sides? Hiya, go.
AB is congruent to CR.
Good. Really, we can just look at our tick marks. We did all the hard work now. TR. All right, what's another pair of congruent sides? Good job. BC is congruent to, you said RQ, Prabnor? Okay. Last pair of congruent sides. Good, hi.
CD is congruent to QS.
Good. All right, there's my sides. Let's do my angles, even easier. Honestly, let's do this without looking at the picture. I can just see the congruent statement. What's my first letter in each one? A and? Good, so angle A is congruent to angle T. Boom. Give me another pair of angles. You said D and S? T is congruent to angle S. Great. What's another pair of congruent angles? You said what? Q and C? Okay. Angle C is congruent to angle Q. So Q, bless you. C. I like it. What's my last pair of angles? Angle B and what? R. Okay. Feeling all right? I didn't look at the picture once for that. I just did it straight from the congruent statement. Okay. All right. Let's complete the following congruent statements. Okay. All right. So the first one is triangle YZW. So YZW would be congruent to which triangle? You be careful about this one. So YZW is to the right. What would it be to the left? This one's trickier. You said what? Why do you say WXY? I agree with you. But why is that the case? Okay. I guess my question is, how do you know that Y and W match up with each other? Okay. Parallel lines imply what? Yeah, particularly in this case, alternate interior angles congruent, right? Very good job. Cool. All right. Next one. MQN. Am I moving this around? Okay. Okay. MQN would be congruent to which other triangle? MQN.
NPO.
You said what?
NPO.
Not NPO.
OPN.
OPN. If you look, M and O are the ones that have two arcs on those angles. So those are the ones that are going to correspond with each other. Okay. All right. Questions there? Okay. It should take a little longer to go through this than I thought it would. That's okay. All right. Triangle NEF is congruent to triangle MGB. Name the corresponding parts without a drawing. I want to do this fast. Sides, angles. Okay, I'm not drawing a picture. We're just doing it straight from the congruent statement. Give me a pair of sides that would be congruent from my congruent statement. You said what? Good. NE is congruent to MG. First two letters. I like it. Keep it rolling. What's next? Let's do the last two letters. That would be what? EF and GB. Good. All right. And then I would have to do the first and the last, right? So NF. Dude's a good rapper. NF is congruent to what? MB. Good. Let's do my angles. So I just need to list one single letter in order that it's given to me. So what would be my angles that would be congruent? Angle N is congruent to what? Angle E is congruent to what?
G.
And then angle B is, oh, I'm sorry. I went in opposite order now. Angle B is congruent to what? We're going the other way this time. Angle F, right? Because B was the last letter. So then F's going to be the last letter. All right, cool. All right. I don't feel like doing example 4. More of the same. You guys okay with that? Are we starting to get the pattern? Order matters? Great. Okay. All right. So congruence of triangles is reflexive, it's symmetric, and it's also transitive as well too. Okay. So what reflexive means is triangle ABC is congruent to triangle ABC. Okay. And then I could say if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So that is reflexive. This is symmetric. And then transitive. How many triangles would I need to show for transitive? I'd have to have 3, right? Because for transitive in the past would be like if A equals B and B equals C, then A equals C. So I'd have to say if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle XYZ, then triangle ABC is congruent to triangle XYZ. Is it necessary for you to write all that? Nah. I wouldn't say that's very necessary. Okay. Now, there are 3 congruence transformations that we can state as well, too. Did you guys do transformations in Algebra 1? Like, what a transformation is a way to, like, something on its coordinate plane, like shift it or reflect it or, like, rotate it. Did you guys do with those? Did you do them in Algebra 1 or in middle school? Like rotations and reflections?
I don't know.
Not sure? Okay. All right. Well, one or the other, right? Okay. So 3 congruence transformations that we can see. Okay. First one is translations. In parentheses, I'm going to put shift. So it's like shifting something up, down, left, or right. So shift/slide. Okay. Another congruence transformation, which means if you do this transformation, it still maintains its shape and size, would be a rotation. So rotating something about a fixed point, rotating it, anywhere between 0 and 360 degrees. And then the last one we could talk about is a reflection. Okay, so you reflect something typically over a line, whether it's x-axis, y-axis, horizontal line, vertical line, diagonal line. So if you take a triangle or any shape and you do any of those transformations to it, it still maintains its size and shape. Okay? All right, you ready for a massive proof? We want to prove that these 2 triangles are congruent to each other. The only way we know to do that would be to show all 6 pieces of information. So you have to show 3 sets of sides are congruent and 3 sets of angles. So we're going to write a long proof here, if that's okay with you guys. No arguments? Perfect. Let's do it. Hey, there's a lot of things listed there as our givens, right? So let's start by writing out all my givens. Landon, you good?
Yep.
My first given is that triangle MXR is right isosceles. I'm not going to write out that whole thing where it talks about like angle X being the vertex angle, but I do have to state my given. So I'm going to start by saying that it is a right isosceles triangle. Okay? Given. I'm going to list them all in that first statement, though. So then the next one, what does that symbol mean? XY is what?
Perpendicular.
Very good. To MR. And then my next given is Y is midpoint of MR. My next one is angle M is congruent to angle R. And then the last given is that YX bisects angle MXR. Okay, we were given 5 pieces of information. That's a lot. Okay? All right. So my goal is to show that all 3 sides of one triangle are congruent to all 3 sides of another, and all 3 angles of one triangle are congruent to all 3 angles of another. Okay? So we're going to get what we can from the picture, and we're going to get what we can from our givens as well, too. Okay? First thing says that triangle MXR is a right isosceles triangle with X being the vertex angle. Okay, so right isosceles. So what does it mean if a triangle is isosceles? Yeah. two of the sides are the same, which results in two of the angles being the same as well too. So which two sides would be the same? If I'm saying MXR is a right isosceles, which sides would be the same? Nope, not MY and MX. So MXR, this whole big angle triangle, is isosceles.
MX.
And good. So MX is going to be congruent to XR. Okay? So I'm going to use that given to list that as a statement because I want to list six things that are congruent to each other. Okay? So Julia said MX is congruent to XR. Cool. That gives me a side. Now I need a reason for that. How did I know those sides were congruent? It was because what? Yeah, it's because it was an isosceles triangle. So we're going to say definition of isosceles triangle. Good. We're going to use some new reasons here that you guys haven't used yet, but I think you'll be able to reason through them, no pun intended, pretty easily. Okay? All right, so then, I don't know if you guys noticed, but I denoted this with an S off to the side. I'm going to do it in a different color. So this shows, okay, I've shown one of my sides congruent. Okay? All right, let's go back to my givens. Then it goes on to say XY is perpendicular to MR. What does that mean? XY is perpendicular to MR. Haya? Just thinking out loud. Okay. 90-degree angles. Where? In the middle. The top middle or the bottom middle, Chris? The bottom middle. So these guys are going to be right angles. Okay. So I'm going to go ahead and state that. That's my next reason. Angle MYX, comma, angle RYX are right angles. Now, how could I say that? How did I know that? I know this is a boring one. I get it. Definition of what? I like it. Not quite. What did they give you? They gave you that those lines were what? Perpendicular. So that's what we're going to use. Definition of perpendicular. Okay. All right, but what do you know if they're both right angles? You said what? That's true. What else can we get, though? The goal is for us to show that they're congruent. Can I say they're congruent to each other? For sure. They're both right angles. So I had a theorem, right angle congruence theorem, that would allow us to say angle MYX is congruent to angle RYX because they're both right angles. So my reason for that would be right angle congruence theorem. All right, cool.
Are we still gonna use like the if? Like whatever it's called, we say if. Blah, blah, blah.
If corresponding angles are congruent, the lines are parallel. We'll probably use that at some point. We're more likely to use the fact that, like Landon, it's probably more likely that we'd be given that lines would be parallel and we'd want to show angles are congruent. So we'd actually probably use corresponding angles theorem instead. But we'll come across that bridge very soon. All right, I've shown two sides. Let's go to my next given. So we use we use that given. We use this given. My next one is y is the midpoint of MR. Oh, that's an easy one. So y is the midpoint of MR. What does that tell me? What's equal? Good. MY would be congruent to YR, right? If it's the midpoint. So let's say that. Bless you. So MY is congruent to YR. Okay. And what would be my reason for that? Good, Max. Definition of midpoint. All right. I showed all my sides. That's all three sides. Someone breaking into my minivan out there? They better not be. All right. Now we're after our angles. Okay. they gave us one of our angles. That's cool. But we've got to show two other angles. Okay? Oh, wait. Sorry. I labeled something wrong. Did you guys see that? For 4, that's an angle, not a side. So this is an angle. Okay? So far I have 2 angles listed and 2 sides listed. That means I still need to show 1 set of sides and 1 set of angles. Okay? We did this. We already used this because it told us that those are congruent to each other. So now we got to do YX bisects MXR. So MXR is the angle that's being bisected, and YX is bisecting it. What does that mean if an angle is bisected? What does that give me? 2 congruent, 2 equal parts or 2 congruent angles, right? I forgot I told you guys if I say bisector, what do you guys say? Yeah. So, okay, I know it's being bisected, so I'd get those 2 angles that are congruent to each other. So I would say angle MXY and RXY are congruent to each other. So 6 is going to be angle MXY is congruent to angle RXY. And my reason for that would be what? It's because that angle was being bisected, right? So would it be fair to say definition of angle bisector? Sounds good to me. There's so many things. Don't worry, I have kind of like a word bank that's going to be coming your way soon. Make it a little easier. Okay, I've shown all 3 angles, swish, but I'm still missing a side. I'm out of givens. So I actually have to go to my picture. Which side am I missing? Which side did I not mark up? I already knew these angles were congruent. They gave me that. Which side did I not mark up in my picture? Not the bottom, because we had MY and YR. You said what? Okay. So is that in the left triangle or the right triangle, Max? You were about to say what? It's in both, right? Like YX is a part of the left triangle, it's a side of the left triangle. It's also a part of the right triangle, right? Do I know that YX is congruent to YX? That's the same freaking side, right? So it's going to be congruent to itself, okay? Now, how would I state that in my proof? This is the moment you guys have all been waiting for. YX is congruent to YX. What reason would I use to justify that? No. Yes, it's reflexive. That's when it was repeated itself. So YX is congruent to YX. I know all the while you guys were thinking, why the heck am I learning reflexive? Like I'm just stating that something's equal to itself. Like when am I ever going to use that? We are about to be using reflexive sides so often because we're going to have like pictures that like butt up against each other. So when that happens, then we use reflexive sides. Okay, I kept track. Did I list 3 sets of sides? Do I have 3 S's over there to the left? Did I list 3 angles? Do I have 3 A's? I did. So now I can say that those triangles are congruent to each other. What are you pointing at, Julia? You good? Dang it, dude. Oh, that's my bad. Sorry, I'm trying to finish. Anyway, that would be reflexive, and then you would state that those triangles are congruent. Definition of congruent triangles. All right, let me pass out your worksheet. Yeah.
I'm not throwing papers, I swear.
Dude, how did that?
I don't know, what you mean?
I like you grabbed it.
Hey, can we just do the front side? Put it on easy mode, do the front side real quick. That shouldn't be too hard for you guys.
Front side evens?
No, all of the front side. And then we'll do the back tomorrow.
Yeah.
Okay. Go ahead and drop your worksheet. What's the next one? Oh, so we can put it on the ground?
Yeah. No, the guy on the board.
Yeah, the
Yeah. Dude, I
All right, bye guys. Have a good day.
remember when the guy bought first came to rescue me? Do you remember?
Yes, I do.
That was so fun.
So someone in
guys win.
single